So here I've got 3 generations of the Cyrus zero feedback monoblock amplifiers. We've got the very early one here, the APA 7.5, roughly 25 years old. And then we've got the MonoX and I've got the MonoX300. And there is obviously the signature unit of this now. I don't have one of them, so that's not part of this, what we're going to do today. But for some time I've been aware that the MonoX300 is a noisier amplifier. I can hear 50 Hz hum from my loudspeakers, and when we look at the spectrum from this amplifier, I've done that in some various other videos, you can see that the spectrum is not as clean, and some folks have commented on this as well. So I thought what we would do is do some comparisons of the noise floors between these different generations of unit, and then see if we can figure out what's going on with the X300 and see if there's anything we can do to fix that. So let's first of all we'll go and look at the noise floor spectrum out of these things and do a comparison and see what our baseline is, and we'll go from there. So this is our APA 7.5 connected to the audio analyzer, just looking at the noise floor. The input's terminated and the output has an 8 ohm load, and we're just measuring across that 8 ohm load, looking up to 20k on the frequency just at this noise floor. There's no signal obviously here with the termination on the input. And we've got noise floor there about 120, and we've got a little bit of 50 Hz leakage here, down about minus 90 dBV. Anyway, let's just put some averaging on here before we do a comparison. So that just quietens down the measurement there, much more clear to see the noise floor. So that's all good. Everything we see here is as we expect, and quite happy with that. So what happens then? What happens if we look at the Cyrus MonoX200 or 300? And this is what happens here. This is what we're seeing in the red trace here. We're seeing this horrible spectrum here with a whole bunch of 50 Hz, 100 Hz going all the way up the spectrum, and we've got this horrible signature going on here on the output of this amplifier. And we can also see that the noise floor's raised here. We've maybe got about 5 dB difference in the noise floor. So that's a little bit concerning. But this here is just horrible. And you know, at first glance you look at this and you think, okay, this is a faulty unit. This is, you know, we've seen this kind of stuff before where some of the low current power supplies go wrong and we get this kind of garbage on the output. You're just seeing 50 Hz, 100 Hz, and it's harmonics. However, that's not what's happening here. This is a fully functioning unit. This is what you get with the MonoX200 and 300. This is the characteristic here. So I've seen this for a long time and I can hear this. You can clearly hear the hum from your loudspeakers. So I thought I'd go and investigate as to why does the MonoX200, 300 do this, and is there anything we can do to cure that. Before we get into that detail though, let's take a look at the wider spectrum. We're going to 20k here, but let's go a bit higher up in the spectrum. We'll see what other stuff is going on in the band here. Alright, so we're now looking at up to 500 kilohertz, just to see what other junk's in the spectrum of this amplifier. And again, this is my APA 7.5, and you can see some of the filtering in the amplifier there. This is just rolling off the noise floor as we get up way beyond 100 kilohertz there. And we've got a couple of spikes, but they're very low level, and I don't think these are related to the amplifier. These are just pickup. And again, we can see here some 50 Hz and a little bit of 100, etc. Let's then now look at our MonoX300 on top of this, and we can see the junk down at the bottom end that we saw before. We also see this much louder junk at the top end here. With a big component around 50 kilohertz, and you can see there's some width to that, you know, there's some modulation on that, and then we've got the second harmonic of that, and so on. And this is coming from the switch mode a standby power supply here. So we've got this extra junk in here that just is horrible. Yes, it's outside the audio band. Your loudspeakers may well still respond to this at 50 kilohertz, and you know, who knows what sort of undesired effects that's having, but it's just horrible, and that shouldn't be there. And you know, I've commented before that when the main amplifier is turned on, that this stuff should just disappear. You know, that supply should be switched off, and this should just disappear. It's fine enough for a digital standby supply, but having this present in your audio spectrum, I find unacceptable. And indeed this is unacceptable as well. You know, the Blue Trace here is like over 25 years old. This is our bass instrument, our bass amplifier, and this red trace is what we get now. You know, so this time has passed. We've done all sorts of development on these amplifiers apparently, and this is what we're presented with now. I just find this astonishing, you know, and of course these MonoX300 300s are considerably more expensive. Every time there was a new revision, you know, the cost was doubled. So we're paying a lot of money, and we're getting this considerably degraded performance. Anyway, let's go on and see what's causing this and see if there's anything we can do about it. So let's take a look at the architecture of these amplifiers then to try and help us understand the problem that we see here. In all of these amplifiers, everything from the APA7 up to the MonoX300 signature, they all share the same architecture here. Got 3 stages, which is common with most amplifiers, but this is obviously a very different animal here, given that it's a zero feedback design. And what we find is the first stage is our voltage amplifier stage. We then go into a buffer, and then our output stage is the current amplification that drives our loudspeakers. And we can see the output stage is driven from an unregulated supply. That's very common. And then these first 2 stages, we've got a regulated supply that's driving these. And we've also got this enable here that controls all of these sections. The first 2 sections here, they've got a current source, and we essentially switch that current source on, and that enables the amplifier. And then the last output stage here, there's a relay that acts as a mute, and then when the relay is energized, you know, our output's active and we can drive our loudspeakers. So obviously we saw this horrible signature on the output, you know, our loudspeaker, and I commented I could hear it, and you know, it's very, very obvious on the spectrum, and I could trace that all the way back to the output of the voltage amplifier stage. And so if we look at this section here, we've essentially got 3 inputs to it. We've obviously got our audio input, and so the problem could be coming in there somehow. More commonly though, and we've seen this on other amplifiers, we could have a problem with the power supply here. But as I've commented, this is not a faulty unit, you know. So you know, our power supplies are just fine. What we also find is that this a current source here that we enable, that's also an input. And this is where I found the problem to be. The junk was coming in on this line here, and that's what's causing our problems. And what we see is that this enable line for the earlier amplifiers, the MonoX, APA7, etc., they all had a 5-volt line. And then the X300, 200 signature, they dropped to 3.3 volts. So this is the constant current source arrangement here, and what we find is we've got an NPN transistor, a PNP transistor, an LED, and then a series resistor. And if we look at it, if we put 3.3 volts on the base of this transistor, that's got to forward bias this junction, the LED, and this junction. And if you look at those items on their own, you know, you've got 0.7 volts here, 0.7 volts here, and then maybe 1.8, something like that on the LED. So then we're very marginal actually for forward bias and all of this stuff, and so we're not actually setting up a proper a constant current here. And this 3.3 volts comes from the digital section, comes from the programmable device on the front panel. And so this is going to have any digital junk on it that's you know, coming from that device. And looking at the spectrum here of this control line, this is what we have. Now if this was just a DC power supply for a digital circuit, you'd be quite okay with that. You know, the levels here are -70, but this is essentially enabling our analog section. You know, it's enabling the amplifier. And what we find, because this is marginally being turned on, then any junk on that waveform, we actually see it starts to modulate this current source, and then it becomes apparent on the output. And as I mentioned in the previous slide, the APA7 and the MonoX, they have a 5 volt control section. And so, you know, if you put 5 volts on here, you've easily got enough to forward bias all of these junctions and then set up a current through this resistor. So this is our this is the core of the problem here. We're not driving this thing hard enough to turn it on properly, and then it's a noisy control line in the first place. And so this is the summary essentially then, and it's kind of hard to take in. You know, this is quite basic stuff. It's hard to understand that this reached production and was obviously accepted. But this is what we have, so let's see what we can do about it. Alright, so if we look at this constant current source enable, we saw the spectrum on the previous slide there, and then if we compare it with what we see in the output, we can see, you know, this same signature is there. It's slightly attenuated, and obviously the noise floor here is a bit higher, but we've got the same signature, so there's absolutely no doubt that this is where our problem's coming from. So if we can smarten up this current source enable, we should solve this problem. So how best might we go about doing that then? We need to generate a clean 5 volt control line as the constant current source enable for these amplifiers. And there's an endless list of options of how to do that. Some are more complex than others, and so here's a few options I've listed here, and you know, we could just essentially need a level shifter, or we could use some transistor or comparator circuit to act as a level shifter. We could use a voltage reference or a voltage regulator to generate 5 volts, and you know, maybe have an enable line that turns that on. But in this case, I think the simplest way forward is to take the 15 volts that's in the unit, and we'll just divide that down. We'll divide that down to 5 volts, and we'll put some filtering on it, so we create a very clean 5 volt line. And the one issue with that is that we don't have a turn on delay. What we find is at the moment that when you turn the amplifier on, there's a couple of seconds delay before the enable line triggers. And we really want to have that replicated in whatever we do here. So what we'll do after we generate this 5 volt filtered line, we'll just use a transistor switch, and we'll drive that from the existing enable line. And just one note of caution there is we need to then check that we don't simply feed the junk through our new circuitry. So we'll check that when we're done. But this is the kind of circuitry I've got in mind here. So we take our 15 volts, and then we've got a resistor divider here to generate 5 volts. And we've got a capacitor across that, so that's going to give us some filtering. And I've got a series P-channel FET here, P-channel MOSFET. When we come along and we use our existing enable line, we'll use that line to drive this transistor. That pulls this potential down, turns this transistor on, and we get our clean enable out of here. So this is the plan, and let's go and see how this is going to work in reality. So here we are again looking at the enable for the constant current source. and when I make up some circuitry to divide down the 15 volts and create a reference from that to use as this enable line. Let's take a look at the response we get from that, and here it is here on the blue. And you can see, if we look at the 50 Hertz component there, we're just a bit above the -70, and here we are about 125. So I've got a good 55 dB extra rejection on that fundamental 50 Hertz, and of course all of this other junk's attenuated equally. And our noise floor, I'm basically at the noise floor of the analyzer here. There's just nothing there at all apart from these kind of random spikes here. So a considerable improvement, and actually so very easy to do. This is just a few resistors, capacitors, very easy to do. So this gives us now a very, very clean reference that we'll use to switch on the amplifier section. So what I need to do now is actually create a mechanism where we actually switch this on and off. So I'll go and add that to my circuitry and see how that behaves. Alright then, so we've got our little circuit board here, and I've got it loosely connected into the unit right now just so we can do our tests. So I've added the switching circuitry now, and so we'll just check the timing and that's all okay. We'll check that the turn on delay is fine. So what we're doing here is I'm monitoring the 15 volts coming in on channel 1. Channel 2 sees the output. This is our new generated enable line. So if I turn on the unit now with a single capture, we should see that timing on the scope. And there we are. So the green line is our enable line. So that's coming on there just fine, and it's coming on 4 divisions after our 15 volts comes up. So that's a 2-second window there. So that's just doing exactly what we want. Quite happy with that. Before we install this into the unit, I'll just go and measure the noise floor again. Now that we've added this switching circuitry, we'll just check our noise floor is all good, and then we'll add this circuitry into the unit and check the noise behaviour of the whole amplifier and see how that's looking then. So here's my little PCB, and I've already checked the output after I added the transistor switching, and it's all good. And obviously this is a prototype. These amplifiers are my own, so I'm quite happy to use prototype little board here. If there was the demand, I would get some custom boards made and then we'd go from there. But my plan here is I'm going to look to use some high temperature silicon, and we'll secure the board in here. And then we need to get access down here for our wiring, so that's the kind of most sensible position. If I did go for a custom board at some later point, then maybe I can use some of this free space on the PCB here to actually locate the thing, but we'll see. That's fine for now though. So I'll go and wire this in and then see where we go. Here's a little upgrade board in situ. So we're now ready to go and see how the amplifier behaves with this all connected up. Here we are after we've done our little upgrade then, and the blue is still our APA 7.5, and then the red is our MonoX300, and we can clearly see that horrible signature that was there before has completely disappeared. The 50 Hertz is even lower than the APA 7.5, so that's pretty good stuff there. We do still see that the noise floor on the MonoX is sort of probably 5 dB higher, and when I look at this I can see that this is due to just a small change in the architecture of the gain stage, and obviously that change has been made for some benefits, and this is a side effect of that. So I'm not going to do anything with that. These levels are low enough that I'm not overly concerned about them. And I can explain it, so I'm happy enough that that's something I don't want to be messing with. The main thing is that we've got rid of that horrible signature that we could hear, and when I connect these to my loudspeakers now, I don't expect to hear anything. So that's the next stage. Then let's hook these amps up to the loudspeakers and see how we go on. Here's the pair of MonoX300s then, and they've both now had our little upgrade mod, and I can put my ear right next to the loudspeaker now and I cannot hear a thing, absolute silence. Whereas before, whenever you went anywhere near the loudspeaker, you could hear the 50 Hz coming through quite clearly, quite obviously. So very happy with this little mod, this little upgrade here. So all that's left to do is to play some music.
Sunny, yesterday my life was feeling